Hey guys, welcome back to C hash or C sharp tutorial session 15. In today's session, you can learn about casting and type conversion in C hash, implicit or automatic time conversion and explicit conversion, along with few of the important type conversion methods. C hash is statistically typed at compile time. Hence, after a variable is declared, it cannot be declared again or assigned a value of another type unless that is implicitly convertible to the variable's type. Sometimes user might need to copy a value into a variable or method parameter of another type. For example, user might have an integer variable that they need to pass to a method whose parameter is typed as double. So this kind of operator are called type conversion in C hash. User can perform the primarily following two kind of time conversion in C hash. One is implicit or automatic time conversion and another is explicit conversion or casting. So implicit or automatic time conversion, no special syntax is required because the conversion always succeeds and no data will be lost. Example include conversions from molar to larger integral type. Like if you convert from byte to short, short to int, int to long, long to float or double, there will be no error at all because they are conversion compatible by default in C hash. Now let's try to understand what is implicit or automatic type conversion in C hash. So I will define some variable here, say integer data type. So integer my int, I can give some value as 40, right? And I can create one thing called integer or maybe byte, my byte equal to say 30. Okay, then so from byte, right, byte is the lower precision value. So if in case you want to convert from byte to short or integer or long or float or double, it will not be a problem. So say I want to convert it to from the byte to maybe integer, right? So int int I can give something called int my int 1, okay, equal to, simply I can use that variable my byte. So that is the way, right, I can convert it easily, okay, and it is not throwing an error. Similarly, if you want to change like integer to the upper precision like long, float or double, you can do it. So say I will be using double, right, my double equal to the I am assigning the my integer. Similarly, if I want to convert it, right, to decimal, say I am giving some variable called my decimal, and then from the byte, then I already converted to integer, and then I can convert it to decimal as well. So that is the way I can easily convert and it will not give any error. Now see if I want to print it out, console or dot write line here. So I will be printing first my byte, then I can print my int 1, my double and my decimal, right. You can see it will be printing the value without any error in the console. So that is called implicit or automatic type conversion, means conversion is happening automatically without any error. So conversion from smaller to larger integral type is possible. From byte you can convert to like any other higher precision Short you can convert to any higher precision. Integer you can convert it to long, float, double. Similarly, long you can easily convert to float, double, and float you can convert to double, but not the vice versa. That is not automatically possible. So now see here the output here. So first one I want to print out my byte value, it is 30 here, no error. Then I want to print my int, which is 40 here, so no error. Then third one, my int 1, so my int 1 I am trying to map convert it my byte, so it will be 30 again. Then my double, so my double I am converting my int, which is 40 here. And the last one is my decimal, so my decimal I am converting my integer, which is nothing but my byte variable here, which is 30, so it is coming as 30. Now let's try to understand about the explicit conversion or casting. So explicit conversion requires a cast expression. Casting is required where information might be lost in the conversion or when the conversion might not succeed for other reason. Typical example include numeric conversion to a type that has a less precision or smaller range. If you want to convert double to float, long int short byte, or float to long int short byte, or long to int short byte, or int to short and byte, or short to byte. So there may be compilation error when type not compatible with each other. Okay, now let's see, we already defined something called, let's define something called double, right? So I'll be defining something called double my double 1, and I can give some variable called, suppose say 4456.123, that is the double variable. Okay, now if you want to convert, right, double to any of the type, right, suppose I want to convert double to int, so I am in changing and I am creating a new variable called myInt 2. Okay, and I want to simply convert my double to my integer type. So you could see immediately it will throw you the error, and if you want to run it, right, it will throw you the relevant error. That conversion, right, cannot implicitly convert type double to int, and explicit conversion exists. Are you missing a cast? So you have to casting it in case you want to convert from higher precision to the lower precision or the smaller range. So what you can do, you need to, right, convert it, right. So here instead of my double variable 1, right, you need to change it to integer 1. First you need to casting integer, then you can easily do it. Similar way, if you want to change it to byte, so what you can do, my byte 1, and I can use the byte, and then I can change it to my double 1. So that is the way I can convert, right, from the higher precision to the lower precision, of the higher range to lower range. Now let's try to print out all the variable value here, so it will work. So that is the way. This is called explicit conversion or casting we need to do in case we want to convert from the higher range to the lower range, or higher precision to the lower precision. We need to use the explicit conversion and casting, then only we can work here. So I will be using my double here. Similar way I can print out my other variable value after casting or explicit conversion. So now it is my integer, now it is my byte. Now if you run your code, it should run properly and it should not give any error. So first it will give me the double value, which is nothing, you could see here 456.123, that is the double value. Now the double I am trying to convert it to integer, so definitely will give the integer value 456 here. Okay, and now if you want to change it to byte, so it will give you the byte value. Okay, now if you change it to say 56.123, and if you run it again, because byte will only hold some value, right, which is not 2 to the power 8. So that is the reason sometimes it is not possible. So you could see now it is coming perfectly fine, because byte is also having the upper digit, right, 56.123 and then 56 and then 56. So that is the way you can deal with implicit, which is automatic time conversion, and there is no rule required. You can easily do the conversion automatically from lower to higher integral value or smaller to larger integral value. But in case you want to convert from larger to smaller integral types, right, you cannot do it. It will throw the error, so you have to casting it. That is called explicit conversion. And then there are couple of type conversions method available in C hash. So it is possible to convert data type explicitly by using built-in method in C hash, such as convert.toBoolean to double to string to integer 32, right, to integer 64, like that. So these are the couples of method. To boolean, it will convert a type to boolean value. To char, it will convert a type to a character value. To byte, it will convert a value to byte value. To decimal, it will convert a value to decimal point value. To double, it will convert a type to double data type. To int 16, it will convert a type to 16-bit integer. To int 32, it will convert a type to 32-bit integer. To int 64, it will convert a type to 64-bit integer. To string, it will convert a given type to a string. To uint 16, it will convert a type to unsigned 16-bit integer. To uint 32, it will convert a type to unsigned 32-bit integer. Similarly, to uint 64, it will convert a type to unsigned 64-bit integer. Now let's try to define some variable and let's see how this type conversion method works in C hash. So I will define some couple of variable here. So first I can define something called integer, say I equal to say 55. Then I can define something called double, say D equal to say 78.123, and then I can use something called float. I can declare some variable called f equal to say 89.78 f. So that is the way I can define float. Now if I want to convert, right, the float to a string, then how can I do? I'll be using Console.WriteLine. Then here I can use convert method, right, dot, I can call any relevant variable, suppose this to string. You could see automatically it is coming. So here I need to pass whatever I want to change it, and I need to enclose to it. Similarly, the other variable I could also change it to, right, say D also I can change it to string. Similarly, I can change I also to string. Right now if you execute your code, you could see it will give you the string value for integer, double and float. So first one is the float, so you could see here 89.78, right, for the first one. Second one is double, so 78.123, and then 55. Okay, now there are a couple of methods, right, apart from to string. Say I want to change something to int. You could see if you want to consider int, so it will be giving you 16, 32 and 64. So I can change it right here, the one 16, 32 and 64 as well. So it will be working for the float. Similarly, if you want to convert same way, right, I can convert it to double as well. So for the double variable also it will work. Now let's try to execute your code and let's see what is the output after converting to simply 2 int 16, right, or 32 or 64. It will convert type to 16-bit integer or 32-bit integer or 64-bit integer. Now let's try to execute your code. I want to convert the float or double to 16, right, or 32 or 64. So first it is giving 90. You could see 89.78 means equal to 90, right, because it's greater than 0.5 decimal value. So for everyone, right, it is coming as 90. For the second one, 1, 2, 3, which is less than 0.5, that is the reason is coming as 78 only. This three value is 78. Now if you change it, instead of 1 to 3, if you change it to 5 to 3, you could see automatically the value will come as 79, right, because it is more than 0.5. So that is the way, right, you can deal with this method. You could see now this is coming as 79. Okay. Now apart from that, there are a couple of important methods available called, right, to uint 16, 32 or 64, means it will convert a type to unsigned 16-bit or 32-bit or 64-bit integer. Now let's see. So here I want to copy it, and here instead of toInt 16 I'll be changing it to uint, right, unsigned integer. Similarly to u integers 32 to u, and here for double also I can change it like that. Okay, and here I can give some differentiation. So that you could able to see the differentiator. Now if you execute your code, so it will be giving you the unsigned value. Now you could see here it is coming as 90 90 90, right. Here it is 89.78, it is giving you the 90 90 90 for that one. Now for the second double variable, it is coming as 79. So similar way, right, these are the couple of methods available in the C has for type conversion: 2 boolean, 2 char, 2 byte, 2 decimal, 2 double, 2 int 16, 2 int 32, 2 int 64, 2 string, 2 uint 16, 32 and 64. That is the way it is possible to convert data type explicitly by using built-in method in C hash. So that's all from today's session. Thank you.